Well, welcome everybody to day 2. I'm super excited. Today we're going to have a bit of a different agenda as we talked about yesterday. It's a little bit more forward-looking, sharing a little bit more on kind of where we think things are going, right? So a little bit less product-focused. Obviously, we talked about all the different technologies that are involved with cloud and how that's evolved over the last kind of 10 years. But I think there's one that is sort of inescapable at this point, and that's AI, right? So today we want to spend a little bit more time unpacking where do we think that impacts infrastructure and the management of that, the security of that, how we build and deploy and manage applications. Now, of course, I think AI doesn't exist in a vacuum, right? There was a bunch of foundational technologies that had to be built that sort of laid the groundwork for what we have today. Obviously, cloud brought immense amounts of compute and storage and network. It made it accessible. We had to build a whole set of APIs and microservice applications that now we can sort of MCPify, right? And technologies like infrastructure as code play a key role in allowing tools to actually be able to generate and manage infrastructure in a way that are suitable for LLMs rather than pointing and clicking. So as we think about all those kind of foundational technologies, whether it's the clouds, whether it's microservices platforms like Kubernetes, whether it's infrastructure as code, there's few people better to speak to all of those things than someone who helped build most of them. So please join me in welcoming Brendan Burns from Microsoft to the stage. Hey, Brendan. Welcome. Thank you so much for joining us here. We're super excited to have you back at HashiConf, absolutely. In fact.
Yep.
So I think almost everybody probably knows your name and what you've done for the industry, but maybe just to start us off, give us a little bit of an introduction, not only just to your name, your role, but your history, because I think you've been a part of this journey of sort of building cloud for a very long time.
Yeah, so I think, like a lot of people, I started out as a user deploying microservices and a user of open source. And then I think what you realize over time is you've learned a lot of lessons being woken up in the middle of the night about what works and what doesn't. And so starting in around the early 2010s, we were really talking a lot about how humans are very fallible. And if it's possible for a person to make a mistake, they're going to make a mistake. And I think that led to this idea of immutable infrastructure. And I think Armon and a bunch of other people were there in that moment of talking about how we do immutable infrastructure. And that led to this idea of infrastructure as code, where you're really describing what you want in a text file, and then there's a system that's responsible for making that happen. It delivers a lot of reliability. But I do remember when just like, DevOps or unit testing or any of these moments where we realized there's a better way of doing things, you had to convince people. I did a keynote at one point in probably 2012 where it was all about like, this is what infrastructure as code is, this is why you care. So it's great to see this journey to get here where I think it's something that we just take for granted, like unit testing.
Yeah, no, I love that. I mean, I think you kind of, you beat me to it here, but I think one of the interesting things is, to your point, when we started this, 10, 15 years ago, infrastructure as code was a foreign concept. You talk to people, you get a blank stare, they're like, why would I even want that? It seems slower than pointing and clicking, like, well, why bother? And so I think it was a journey, and then I think it kind of changed over time. Obviously, it started with cloud provisioning tools, then you went to sort of platforms like Kubernetes that embraced it. And so I think it went from almost sort of a thing where people were like, what? To I think now it's like, obviously. But I'm curious to get your perspective of how did that evolve over time, right? It obviously wasn't sort of a light switch, but I'm curious to get your perspective on it.
Yeah, I think there's two things. I think one, the switch to cloud moved a lot of people to be thinking in terms of APIs for infrastructure instead of calling up a computer provider on the phone and something getting physically shipped to you, right? So that shift to an API, I think, naturally shifts you towards describing it as an HCL file or any other kind of infrastructure as code file. And I think in conjunction with that, there was just the rising expectations of customers around how reliable these services have to be, how dynamic they have to be if something goes hockey sticking. And those two things I think came together to force people to really focus on making sure that every single thing that they do is as reliable as possible, right? And that used to be something that was just maybe telecommunications providers or banks, but now it's like every single thing that you put out on the internet has to be at that grade of reliability. And I think everybody realized, just like you need unit tests to write good code, you need infrastructure as code to deliver reliable services.
Yeah, makes sense. So kind of the shifting sort of expectation and that raising tide almost kind of caused this to become almost a default by necessity, more than anything. So, I think maybe looking at where infrastructure as code is today, right? I think obviously we think about it as sort of integral to it, but I think, we certainly see a lot of challenges still, right? It's not uniformly adopted, and I think even when it is adopted, there are challenges there. So I'm curious to get your perspective on where are those gaps, what are the challenges when you kind of see how people are using it today?
Yeah, I mean, I think that obviously, I think we've reached the place where people understand that they should do it. And so some of it is maybe just figuring out how you adapt the legacy forward, and rewrite patterns for that. But I think the other thing that I would say is that, I think even as people say, okay, we'll do infrastructure as code, they're not necessarily seeing the other value propositions that can come from infrastructure as code, where you can, even do things like unit test your infrastructure as code for problems, obviously apply code review, pre-merge validation, you can apply policy, you can do all sorts of these pieces that make the changes that you're making to your infrastructure as code templates and your files more reliable as well, right? So infrastructure as code is great for reliability, but you're still editing it, you can still make mistakes. I've seen someone who, meant to type Australia and typed Austria, right? And it's hard to. And as a result, I think there's a lot of additional things in terms of policy and other kinds of tools that you can layer on top of that infrastructure as code that I'd love to see more adoption of in order to deliver safety and reliability.
Make sure it's sort of governed correctly, is done safely, managed at scale.
Absolutely.
Makes sense. So I think one of the interesting things as we talk about that sort of safety at scale, right, is the scale we're dealing with today is human, right? The tools are sort of written by humans, they're used by humans, they're reviewed by humans. But I feel like we're now going through this transition where it's sort of by agents, for agents, right? And so it's going to be a totally different speed, size, and scale of kind of what we're dealing with. How do you see that sort of impacting the landscape of infrastructure as code?
Yeah, I think there's sort of maybe three things that I would think about. The first is actually, to your point about how do we get everybody there, right? The legacy, it used to be like, well, maybe we won't touch that. I think with AI and agents, it's becoming easier to say like, hey, we did a good job porting this piece. Maybe what we're going to do is apply an agent to do those same changes across the rest of our legacy stuff to bring it forward from a bash script to a Terraform file. I think the second thing is I think we're going to see infrastructure as code change so that agents know how to target it better. Right? One of the analogies I've been telling a lot of people is I feel like we're building these AI agents like we build a self-driving car by building a robot to hang onto the steering wheel. Right? That's not the thing that we should be doing. We're going to see our infrastructure as code adapt so that it is the right primitives for the AI to work on. And then I think the third piece that's interesting is it actually just helps people do a better job because it enables you to look at the rest of the corpus of someone's infrastructure as code, provide the right context in, and that's critical, providing that context, and then have someone who's just joined the company be able to generate infrastructure as code that matches your policies maybe, right? And so, but only if we can get the right context into the agents.
So I think you used the perfect word here, which is context. And I think, we've spent a lot of time talking about this. I think when I look at AI today, particularly in how it's being applied to infrastructure, it's largely context free, right? You have a giant model, it's trained on all of the world's, documents and whatever, but it doesn't know anything about your particular infrastructure. In that sense, it's sort of context free, right? And it's kind of like hiring the world's greatest SRE who knows precisely nothing about how your company operates, right? They're only going to be so useful.
Yeah.
So, I know you've spent a lot of time thinking about this of what's that role context plays in terms of enabling sort of intelligent operations within infrastructure. And so I'm kind of curious to get your view on what's necessary to make that actually productive and effective.
Yeah, I think we used to think about context like it was just sort of the inventory of your cloud stuff, right? And that's sort of where we started, right? I need to know what team is responsible for this machine that maybe has a CVE or this IP address where I see weird traffic. But what we've realized is that context is really delivered by the relationships between things. And we need to be able to understand the dependencies between a DNS address and an IP address, between a server and a database. And so in a lot of the work that we're doing in this Azure resource graph that we've developed, we're encoding that context, even metadata like what's the on-call queue for this particular VM, so we can contact someone about the CVE with automation. And I think there's a ton more that needs to be done in general to be able to bring that context into the AI to deliver the right insights and to also generate the right infrastructure as code.
Makes sense. Well, thank you, Brendan, so much. So glad to have you here and sharing your insights on this. So thank you again for joining us.
Thank you so much.
Thank you so much. Thanks so much for Brendan joining us and sharing his perspective. I think it's invaluable as someone who's sort of been on the backstage of helping build the cloud systems that we all run on top of and the platforms we use. But I think it's also interesting to get the perspective from the other side, right? As an organization who's a large enterprise trying to navigate their way to cloud, adopting these technologies, and going through some of those sort of cultural and technology shifts that make it possible to use these technologies. So please join me in welcoming Tyler from Adobe to share their story and perspective from a customer. Joining us.
Happy to be here.
So thanks so much for joining us. I think probably safe to assume most people know who Adobe is, but maybe just give us a little bit of your name, your role, and at a high level, what Adobe, does for folks that maybe aren't as familiar.
Absolutely. So my name is Tyler Jacobsen, Director of Cloud Operations at Adobe Systems. I work in the cloud operations business, and we run and manage and maintain all the governance for Adobe's public cloud and private cloud. As far as what Adobe does, I think a lot of you in here probably got your first exposure to Adobe, through Photoshop, whether that was a legal or not legal download.
It was definitely a non-legal version.
The ubiquitous PDF, and really the creative side of Adobe's business. But what a lot of people don't know about is our B2B segment and all the business that we do selling to the world's largest organizations and providing software, providing infrastructure in the cloud for those organizations. And these are the largest organizations in media, retail, e-commerce, healthcare. I mean, you name it on the planet, and we probably have been a customer at some point.
Yeah, I think fair to say if you're a Fortune 500, you run on top of Adobe.
Yes.
So obviously a very critical company, and you guys have gone through the cloud transition, right? Very much started in data center, now very much a publicly multi-cloud company. Mm-hmm. But maybe wind the clock back. What did that sort of look like in the early days as you were starting to go through that initial adoption journey?
Well, as I stated before, Adobe is a creative company. That prevails throughout the culture and in our engineering and our infrastructure. And so creativity and consistency rarely converge. So if there was a possible path to public cloud, our teams took it. And so this really created a culture of a lot of disparity in terms of our infrastructure and our security. We also grew by acquisition, and so we are an amalgamation of like 28 different companies. And it's really hard when you integrate a company for them to completely retool their stack. And so a lot of that kind of, I don't know if I would call it legacy, but I would just say a lot of that disparate infrastructure existed throughout our environment, and that was the challenge that we had to solve. So I would say it was relative chaos. There was a lot of click ops going on. There just weren't a lot of paved paths and consistent documented methods to get infrastructure out to cloud, defining whether this is more valuable in public cloud or in our private cloud. So yeah, it's just a very fragmented landscape.
A very creative landscape.
Yes.
So maybe what was that journey then to coming to IAC and really standardizing on that as sort of an approach for how cloud got managed?
Well, I think the organization really quickly understood that how are we going to scale? And how are we going to keep up with the scale and the demands of the business in this fragmented infrastructure? And so, even though our organization is a revenue enabler, we're still a cost of goods sold, so it's not like headcount is just handed out like candy. So we were forced to make a shift to automate, to define, infrastructure as code so that it was reusable, predictable, consistent. So we spent less time firefighting in critical service outages. And yeah, we knew we had to be able to deploy faster to meet the needs of the business because the scale was growing so quickly.
The scale kind of forced it.
Yeah.
And so I guess as you guys got to that point of high level of adoption and more standardization, what was that impact in terms of sort of the velocity that it unlocked?
Yeah, so we started seeing it early on just in terms of just less outages because we had more consistent infrastructure and we weren't making mistakes because a script went wrong, or we accidentally provisioned the wrong memory or disk size in one environment versus the other. And so we really focused on creating what we call a platform management module on how do we template and design all of these reusable modules that we could publish and share with our product teams. The benefits we got from that was a huge improvement in developer velocity, abstracting all of that from them so that they could focus on building their product, building revenue, instead of focusing on trying to build security in and understand the language of these various infrastructure applications.
Right. They focused on what they cared about.
Yeah.
So I guess that's an interesting point, which is then as you brought in tools like infrastructure as code, you guys obviously brought in Vault and drove secret management as a standard. But then did that end up creating sort of a skills gap where you have all these kind of new tools, platforms, technologies, but not everybody knows actually how to use them and leverage them?
It absolutely did. Kind of what I was mentioning before, we didn't want all of our engineers to have to know Vault, to have to know Terraform or HCL. And as all of those skill sets in our industry just keep getting broader and wider, it's impossible to be kind of the master of everything. And so we wanted to be the masters of the domain we could control and let them focus on that. So we really built it so that we could abstract the tools as much away from them. If they were a power user, then of course we would still expose all the backends and let them go at it. But for the average user, we just wanted everything to be completely packaged up, defined, and secure by design, secure by default, so that they didn't have to think about it.
Right, make it easy.
Yep.
And so I think that simplicity is probably what enabled you guys to really unlock the scale of usage that you're operating at today. Maybe give us a sense of what is that size and scale of the environment?
It's a little hard to define. It's in the hundreds of trillions throughout the year. I think it got so big we stopped tracking it. But again, I was talking about our customer profile. Between now and Christmas, anything you guys do online, whether it's Black Friday or all the Christmas events or holiday events, everything that you guys are getting in your email, the push notifications, all that curated content, that is all being generated through our systems, and it's in the trillions of transactions throughout that period, and it's one of our biggest and busiest times. But as far as the scope of what we're servicing, it's thousands upon thousands of apps, tens of thousands of microservices. We've got 900 distinct teams that we've onboarded to our services and have tried to create that clarity, that consistency across all of that, but also give them the flexibility to be creative,
right,
at their application level. So
given that huge kind of scale, how does that end up translating into sort of the operational complexity then of that environment?
I think what we're trying to do is really limit the blast radius of the consumption of our services, so that if we have a problem with one product, we're not impacting 30 others. I think just creating those guardrails to get in front of the problem and define that through code and have that all templated and modularized to avoid a lot of the common issues that we've seen other teams go through. So hopefully we're learning our lesson. And then, how do we continue to scale out? Some products have limitations in being able to scale out horizontally. Do I want to create a bunch of more disparate infrastructure to try to build at that scale? And so we're just thinking, how do we, Hashi's products, how do we, just create that cattle, not sheep mentality, and just be able to add clusters to go with the growth, but limit the blast radius and the impact by segregating that out.
So maybe kind of last question for you. How do you think about the opportunity of applying AI then to solving some of those kind of operational challenges you guys are seeing?
Yeah, so most immediately what we're looking at is, how do we wrap MCP around all of our services so that, again, people who don't know, the code or the technical aspects of our various technologies, that they could speak to these services using natural language, and be able to just pave those use cases, those workflows for them. And then on the back end, that we're again building all the security guardrails that we can up to this point. These things are all so very new. It's changing. It feels like every 48 hours. And so trying to keep up with it. And I think this is a big problem for the industry as a whole because it is changing so fast. And we try to standardize and adopt on some AI tool or AI capability, and like 2 weeks later, someone's talking about a new standard. So it's like, how do we standardize on the usage patterns?
Yep.
And instead of the actual tooling. But yeah, this is a big problem that's starting to scale, and we're looking to figure it out.
Love that. Well, I love that workflows over technology view as well. Very much resonates. And Tyler, thanks so much for joining us and sharing your perspective.
Thanks for having me here.
Thank you so much. Thanks for joining me, and thanks, Tyler. Thank you so much, Tyler and Brendan, for sharing their perspectives from both industry and customer perspective. And I think what I appreciate about kind of hearing it from both sides is you can kind of see the resonance of the same themes, right? When we talk about some of these things like infrastructure as code, you kind of hear that the forcing function in some sense for adoption was we needed to get to automation. The size forced us, the complexity forced us, the need to get to sort of more repeatability, lower error, kind of drove that. And then it's like, okay, but how do you go further than that? You need to bring in things like policy as code to put the right guardrails, put the right sandboxing in place. And ultimately what that enabled was a reusability and a scale pattern, right? But all of these things have their own challenges as well, right? And so I think the flip side of all of those things is, while it solved for these problems, it introduced a skills gap, right? Not everybody sort of is aware of these tools, knows how to use them, is effective at them. How do we govern them at scale, particularly as you get bigger and you have those blast radius issues that we have to talk about? And then you think about the complexity of these environments. Once you start talking about tens of thousands of microservices, it becomes very challenging to reason about those estates. And I think the backdrop of that is then, okay, well, what happens as we go through these inflection points? Already today, I would probably estimate we see maybe 30 to 40% of Terraform code being written by tools like AI, and rather than being written by humans. And so how long until that's 100% of the code, right? How long until we're getting vastly outstripped in terms of the generation, the review, the governance of all of that? And so I think it puts us in this interesting challenge, which is in many ways we're now facing a next set of these problems from exacerbating the governance and scale issues. And in some sense, the technology that created the problem with AI is also the technology we have to leverage to solve those same problems, right? And so for us, we've been spending a lot of time of, well, what evolves as we start thinking about that next generation of sort of an AI operating model, as we think about how are we managing our applications, our infrastructure, the security aspects of all those things. Obviously we've talked about hybrid operating model for a very long time, so there's sort of this natural evolution of what changes once you start AI augmenting, every layer of that stack, right? So we wanted to give a little bit of a sense of like, how are we thinking about this growing up, right? Starting with the agentic applications, I think this is probably the most straightforward, right? And I think we're already seeing this kind of in full force. You can almost look at it as there's two different sides to this. One side of it is, maybe we're using tools like AI and using technologies like Cursor to write the applications. And in that sense, it's changing the workflow and the SDLC. But we might equally be writing applications that leverage inferencing as part of how they run, right? So not just using it to write the application, but how the application itself operates is based on inferencing. So I think in that sense, we're seeing this change in the SDLC, how we have to govern this, how we have to think about securing it. If no one human is writing that code, then surely it's not going to scale to have humans reviewing it. So we have to kind of think about these things in different ways. But we also have to embrace it. It feels inevitable that this is where it's going because it's solving that skills gap issue. So one of the pieces that we've been excited about has been the introduction of the MCP server for Terraform. Right, and this goes back to that skills gap issue. We see a lot of people who want to write Terraform but maybe aren't familiar with cloud, aren't familiar with Terraform. And this has really been helping lower the bar for them to be able to come in and say, okay, what's my intent? Can it get me 90, 95% of the way there? And that's a huge reduction of sort of that barrier of entry for new people coming in, right? So I think there's a ton of value in this, but it has to be done carefully. And this then puts pressure on things like policy as code, because we now have someone who's maybe less familiar writing code and they're not going to catch maybe some of the security issues or governance issues relative to someone who might be more of an expert, right? But then the area that I think we're spending probably more of our time thinking about is on the agentic infrastructure side of it. What changes there? What's the middleware that's required? How does the governance of this stuff evolve? And I think we're starting to see some patterns form across industry. Obviously, it's early days, and as Tyler said, every 2 weeks, the landscape does appear to change. But I think if we zoom out and sort of look at, well, what are the core layers? What needs to be true? I think we're sort of seeing that, we can kind of loosely start talking about 3 different categories of issues within the infrastructure realm. The first one is really the runtime, right? So where are we actually running these applications, particularly the ones that depend on inferencing? And I think it's very clear that this is going to be a hybrid reality, right? Even if you wanted to be entirely one provider, just given capacity issues that we're seeing, you end up having to stripe across multiple clouds, or you're using neo clouds, or you have data sensitivity issues that prevent you from even using a cloud, and we're seeing things like GPU farms being built out in private data centers. So I think this creates the need to say, well, how do I have a runtime that allows me to easily run these types of things that's going to be hybrid, that's going to allow me to kind of access capacity wherever I need it, right? So that becomes clear that there's a need for some sort of a set of runtimes, and we're seeing an evolution of a whole bunch of different tools and solutions in that space. Then the next layer of it's really the gateway. And I think very much as we saw with the microservices pattern, we ended up gravitating towards solutions like API gateways or things like service meshes. We needed something that sat in that network path that gave us a bit more control, right? It gave us visibility into who's talking to what, how are these systems interacting with each other. It also gave us control to be able to enforce which services are allowed to talk to each other's services, in this case, what agents are allowed to talk to other agents or tools, right? But it also gave us a point where we could have things like a registry. What are all of the services in my environment with something like console? What are all of the agents in my environment? And then how do I impose the policy on that to say who's allowed to talk to who, which tools are allowed to be leveraged, right? So there's certainly a need to have something in that network path that's doing the discovery, that's doing the registry, that's doing the routing, that's doing the policy enforcement. And again, there's obviously a lot of protocol evolution, whether we're talking MCP or A to A or other things. But it's clear you're going to have something that's doing that governance in the path, right? And then I think there's the other, even probably bigger challenge, right, that we're just starting to scratch the surface of, which is when you look at the enterprise data landscape, it's not 1 or 2 systems. Most big enterprises maybe have hundreds of different core systems of record. And so the data is highly fragmented across all these things with very different ways of accessing it, very different ways of querying that data, different data models, different access controls around all of it. So how do you then expose all of that to AI in a consistent and useful way? And I think this is where we're seeing a lot of challenge, right? If we're going to actually make most of these bots useful, we have to go from low context, as sort of Brendan described, to high context, which means pulling in these systems and making them accessible to our tools, right? And so I think that's kind of the landscape we see today. When we talk to enterprises, it's highly fragmented. These systems don't talk to each other. There's not easy ways even for humans to look across them, let alone our AI and applications. So to chat a little bit more about kind of what we're seeing around this and where we may be going, I'm excited to welcome one of our product leaders, Jackie, to the stage. Please join me in welcoming Jackie. Welcome, Jackie.
Thank you.
Welcome, welcome. Super excited to have you here today. So I know you've been having a lot of these conversations, talking to customers about their landscape and what you're seeing there. Maybe just share a little bit about what we're hearing from customers.
Absolutely. Customers are lacking this single end-to-end view across their infrastructure and applications. And what this means is that they're struggling to act on the volume of data from applications, environments, infrastructures, code tools like Terraform, and cloud service provider data, which is, of course, shared across lots of teams in their organizations. And it's made even worse by the pressure to keep it current, compliant, and secure. The general technology of a resource graph or a knowledge graph has been shown to create a single view. A knowledge graph is simply a database of relationships and context about those relationships. By focusing on connections, it makes it a great tool of choice for managing infrastructure estates at scale.
I love that, and I think it resonates exactly with some of the challenges we discussed earlier in terms of how do we have that context and not just have an inventory of what's in sort of the environment. So, maybe without further ado, Jackie, do you want to maybe share what we've been working on, around exactly this topic?
Yes, I'm so excited to share with you today what we've been working on, Project Infograph. It is a specialized, yes, that's fantastic. Project Infograph is a specialized and tailor-made graph system designed for efficiently managing multi-cloud and hybrid cloud estates. It will help improve visibility and actionability of your infrastructure. Our graph system relies on a vast ecosystem of connections and integrations to create that single view. And with this single source of truth, critical manual operations go from ad hoc and expensive over to efficient and proactive.
So I think we've shared a little bit of like the what, right? It's sort of this real-time view, graph-based database, so we have all these connectors, but I guess how do we translate that into like what are the use cases for something like this?
Absolutely. So since Project Infograph is solving for this single end-to-end view, it makes it an ideal tool and for directly solving some of these painful remediation tasks, drift detection and resolution, auditing, patching, application modernization, and even cloud migration use cases. Today, we have 3 data sources: HCP Terraform, HCP Packer, and AWS. And even with this minimal set of data, we're able to begin scratching the surface on use cases like traceability of deployed resources in the wild and vulnerability remediation. Let's talk about traceability first. Obtaining that full lineage of a deployed resource and all of the attributes is difficult. Project Infograph helps by focusing on the relationships, which means platform engineers can quickly assess these resources, identify how they're managed, what images exist on it, and even event data so they can get to auditing, controlling, and applying best practices.
So I think this makes sense. If you have the graph, you can start to have that visibility. You can kind of trace the relationships and lineage through this. It feels like that would then naturally lean into things like, okay, once I know what's there, that can automate processes like vulnerability management, for example.
Absolutely. Into the future, Project Infograph will help teams identify CVEs and vulnerabilities in their infrastructure and their resources. Once these resources are available, you can even see how the graph pulls together cloud provider data, tag data, and infrastructure management tools like HCP components. This positions the graph system to help you remediate these vulnerable images by directing you to tools like Packer, where you can revoke the image, update the configuration, and distribute to natural channels. And then, of course, drop you into Terraform, so you can deploy that newly secured AMI to your affected infrastructure.
So maybe I think it'd be interesting for the audience to actually take us through a day in the life of like, what does this actually look like? How would you use it? You know, how does this system actually work?
Absolutely. So let's say I'm a platform engineer sitting at my desk and my boss comes by and says, Jackie, we need a full view of our infrastructure. I want to see images. I want to see cloud provider data. I want to see Terraform versions. Well, normally this would take me a couple days working across 5 tools and spreadsheets, and then I'd give that to my boss. And we'd do another iteration of that. But with Project Infograph, I have a single place to go. I simply log into my HCP organization, head over to the resource graph, and from here I can go into the inventory view to inspect what data sources are in my resource graph. So if I wanted to go to AWS and see all the attributes and accounts that I would need to make decisions, I can see that they're right there. Even head over to Terraform to make sure that all the workspaces I need to make decisions are also in the graph. And then finally, image data is so important. I can click over to Packer and view all of the build data that I'm expecting to see. Now, I actually want to see what's in the graph. So let's head over to the Graph Explorer. From here, I can use a pre-built query. Let's take a look at the resources under Terraform management and I get asked about all the time. Here, I can view things that are under management or not under management, and it's done in a matter of clicks. Next, I know that I'm responsible for making sure my infrastructure is in date. So I can use this other pre-built query for EC2 instances older than 30 days. From here, I can inspect the attributes and even drill into specific items to make sure that I have things that need to be up to date and take action on them. Now, another item that my boss is asking about is golden images in cases where they are not managed by Packer. So here, I'll update the query to focus on virtual machine images and make sure that they have an artifact or don't have an artifact produced by Packer. So here, it's a great view of things that I need to make sure to be provisioned by Packer or not. Next, I know that my boss is going to ask about infrastructure and whether or not they're running on the latest version of Terraform. I can clear this query and head over to another pre-built query focused on version of Terraform in my estate. This gives me a field view of all of the resources that are running on an out-of-date version of Terraform. Now, I want to inspect the relationships between these resources. I can toggle over to the graph view. The graph view helps me visualize these relationships and even drill into specific items, giving me a full picture of a blast radius for what a Terraform version update would cause. Now, I'm really interested in the virtual machines here, so I can update the queries and see just virtual machines. From there, I can click into the state file, inspect all the attributes, and even drill into the Terraform workspace. I can copy the workspace ID and go into Terraform and perform an update. Something that would have taken days, maybe even weeks for a very large estate to figure out now just takes minutes, which means I can get to patching, remediation, and updates in a fraction of the time.
Awesome. I think that was an amazing overview of kind of the product today and all the use cases that we think it can solve right away. But maybe give us a little bit of a look into where's this going, right?
Absolutely. So looking ahead, we're very focused on improving the richness of the data in the graph. And to do this, we'll be expanding our connectors, starting with cloud providers like AWS and Azure and Google Cloud, and then of course, expanding to our full suite of HashiCorp products, and even supporting things like custom connectors built by our customers. And then third-party integrations are top of mind too. We want to prioritize version control systems and even security tools like Wiz, and of course, our IBM portfolio. This richness of data allows a perfect foundation for performing agent or agentic experiences. And I couldn't be more excited about the potential of Project Infograph to propel the future of infrastructure management automation.
Awesome. Well, thank you so much, Jackie. This has been amazing. Thank you for joining us and sharing the Infograph product.
Thank you. Thank you.
I'm super excited about this project. I'm super thankful for Jackie to come and join us and share more about this. If you all want to learn more about this, I recommend going to the HCP booth in the HashiCorp zone. But this is, for us, the beginning of a much bigger and deeper investment in really enabling that rich context so that we can bring that kind of AI-powered operations into everything that we're doing, right? Because we think that context is absolutely key to making that powerful, effective, and secure. So when we talk about security, that maybe brings us to that last pillar, right? We've talked about agentic apps and agentic infrastructure, but what about agentic security, right? I joke that the S in AI is for security. And I think we're seeing these kind of issues on a daily basis now. And so if we take a look at some of the challenges, right, I think part of the issue is really that the call chain is very different now, right? It used to be you had a human user maybe talk to a system, talk to a database, but now we're seeing multiple layers of intermediation where it might be a user talking to an agent talking to other agents, and so on and so forth, until eventually we're probably getting to a backend system that's talking to a database, right? And so throughout this process, we have a whole bunch of challenges around how do we know the identity of who's talking to who, what set of permissions and authorizations do they have, do we have confused deputies in the middle that are leading to privilege escalation? And so these are all kind of the security issues that really tie back at the end to really identity and authorization. So for us, as we really think about most of these security challenges, they come back to getting identity and access management right. Right? And if I think about identity, for a very long time, we thought about this as a human problem, right? And I think we got to evolve our thinking to really think about identity as existing on a spectrum that spans from very human-oriented concerns to very machine-oriented concerns. Obviously, when most people think identity, they immediately jump to kind of workforce and user identity, right? How do I have a directory of all my employees and I onboard and offboard them, as they're hired and leave, so on and so forth. Yes, that's very human in its nature. But then as we start moving slightly further, we start thinking about privilege access management. And again, this was very human oriented. It was like, great, how does my privileged user check out a credential and access a database? But now you're seeing that evolve where it's like, well, maybe it's not a user who's connecting to that database. It's actually an agent that's going to connect and run a query and do some data aggregation. So how do you do privilege access for an agent on behalf of a user, right? Then you think about secret management, sort of sits in the middle. Yes, you have human users who need secrets for systems. You equally have machines and applications and agents that need access to them. But increasingly, those interfaces might be different. It might be powered through something like MCP, right? Then as we get into things like certificate lifecycle management, this has been an area of, we've always had certificates, but they tended to be long-lived. We didn't really often tie a lot of access control or entitlement to them. But I think that's increasingly becoming prevalent when we talk about how agents get deployed, how do we manage their identity, how do we govern what systems have access to what. And then ultimately you get all the way to the side of non-human identity. How do we manage all the service principals, all the accounts, all the agents that are operating sort of on their own, potentially, autonomously, and they have their own set of entitlements? How do we govern and onboard and offboard those, but do them in an API-driven, automated way, rather than sort of a ticket-driven, manual way that maybe makes sense at a human scale? So across all of these is where we're invested, right? We've always been focused in sort of the middle areas with Vault and with Boundary as we think about secret management and as we think about privilege access management. Now as part of the IBM family, there's IBM Verify. And I think we're continuing to now think about the other side of the spectrum in terms of how do we continue to invest there and really provide a set of solutions that span that whole spectrum from human through AI and machine, right? So it's an area we're continuing to invest in. I'm happy to share more if you want to chat with folks at the HashiCorp Zone about kind of where we headed here, right? Along the way, right, we talked about wrapping MCP and enabling these things to be agentic, much as Tyler mentioned they're doing at Adobe. We're doing the same thing and bringing those capabilities to our products. So if we look at where we are today, we talked about the MCP interface for Terraform already. We've introduced MCP front ends for Vault and Radar and Console as well. So this is about sort of investing and bringing the broader portfolio. You're going to see us continue to expand this to the HashiCorp products to make them sort of agentic ready, right? So now as we zoom back out, right, we've kind of talked about these different pillars, agentic applications, infrastructure, security. We think all of these are undergoing an evolution, but all of them still need to fit within the broader hybrid cloud model, right? And I think if we then think about the timelines, what's exciting for me is while we're sort of now approaching the mature scale phase of the cloud programs, in many ways we're sort of winding the clock back on these AI programs, and we're very much at the infancy of those. So how do we think about the right ways of the set of middleware, the controls, the stack, and how that's going to evolve over time? And it's exciting for us to be a part of that journey for the next 10 years. So as we sort of think over the course of a decade, someone that I think has played a very key role in helping build and evolve many of these cloud technologies and programs is someone that I'm very, very excited to welcome as a very special guest today. Joining me in welcoming Mitchell Hashimoto back to the stage. I'm super excited to have you back here. It's very fun, especially for this moment. But I do think I need to address the obvious question in the room, which is, did we coordinate on the colors? The answer is no. We both just showed up in the garage today wearing olive green.
That's right. That's right. But thank you so much for having me up here. I'm nervous, honestly. It's cool to be back. And it's cool to be back at the 10th anniversary of HashiConf. That's also very special. And with me came the whole 10 anniversaries of swag and memorabilia and history from all the HashiConfs. And it's just really amazing to see and think that it's been this long of community and builders and ideas, and it's awesome. It's awesome.
Well, it's great to have you back here, and I think if you get a chance, come take a look at this wall. It's fun to see the evolution of not only the company, but the products and the community and all of this group and how we've sort of built this community and built these products together. And I think what's fun is that in many ways, this is sort of only a part of a much larger story. I think what's cool when you come to HashiConf is you see not only the product announcements, but how users are using this to build all of these applications and services that really power the modern digital economy.
That's right, yeah. And this story is a much, much bigger story, right? It's not just HashiCorp, it's not just IBM, it's you guys here in the audience, it's the employees that are here, it's us on stage. It's really like everybody that's a builder and an engineer that's behind the tech that the world runs on. And it's the tech that anybody, just any normal person that has a digital life depends on every single day.
And I think this is a story that's been super exciting for us. It's captivating to think about, sometimes terrifying, our reliance on these technologies that power the world. And this was a story that we wanted to share more broadly. So I wanted to share a quick look at something we've been working on. Let's take a look.
Think about it. One mistake can bring the world to a standstill. In July 2024, planes, banks, and hospitals went dark worldwide. All of it from one field in one file. And this isn't new. In 1962, NASA's first spacecraft bound for Venus lifts off and within 5 minutes of launch, explodes. The cause? What Arthur C. Clarke called the most expensive hyphen in history. Now, tragedies always take the headlines, whereas the miracles get overlooked. Nations saving infrastructure under fire, billions of transactions moving safely, packages arriving in a click. And then there's you, driving down a road you've never been on, just following the map on your phone. And for a moment, that strange feeling hits. You realize you're trusting this thing completely. And behind it all, code. Just plain text, running everything.
I'm super excited. This is obviously just a sneak peek and trailer of a much larger story that we're excited to tell, and you'll see more about that coming. But in the meantime, I want to share Mitchell has some news as part of this project.
Sure, I'm not back, but I am going to help. I am going to help part-time with this project. Armon's very busy, and I just want to make sure that this story is told the right way from the builder's point of view, accurate to how it goes.
Yeah, and I think what's exciting for us is I think the story comes at a very interesting time, right? Obviously, we talked about this cloud era, we've talked about how code plays this important role in the modern digital economy, but I think we're at this very interesting inflection point, right? We're seeing how AI is going to transform the way code is written and how the modern world works. And as we look even further ahead, we see how quantum is going to impact that too. So I think it's a very interesting time to be able to kind of tell that story, reflect on everything that's been built, but also kind of look forward at where this is all going. I want to give a huge thanks to the team that made even this trailer possible and the bigger projects. So Jay Fry, Cole Morrison, Kyle Jones at HashiCorp, Brian Johnson, and Lori Parker at IBM, and the whole IBM Blue Studios. So thank you very much.
And then just as a final note, we'll share more soon as production ramps up. Thanks for building with us, and thanks Armon and everyone else for inviting me back to the 10th anniversary of HashiConf. I'm happy to be here.
Well, we're super excited to have you here. And speaking of HashiConf, we're excited to announce another thing that is coming soon, which is HashiConf 26. So please, please mark your calendars. We're going back to the East Coast. We will be in Atlanta next October. So I hope everybody enjoys day 2 of HashiConf. Thank you, Mitchell, for joining us, and I'm going to hand it back to our wonderful MCs. Thank you so much.